In this video, I'll be discussing the synthesis of macromolecules as well as the breakdown of macromolecules. Recall that macromolecules it's simply a term for a large molecule. So the process for synthesizing macromolecules involves dehydration. Dehydration synthesis is a process in which two smaller molecules become joined together to form a single larger molecule. During dehydration synthesis, a hydroxyl group, which is OH, which is composed of oxygen covalently bonded to one hydrogen atom, is removed from one molecule, and a hydrogen ion, H+, is removed from the other molecule. Okay, so let's take a look at this diagram here. We can see a hydroxyl group and a hydrogen ion combined to form water. So we have two smaller monomers. One has OH, or a hydroxyl group. The other has H, and those come off, and of course two hydrogens and one oxygen, that makes water. So we have, the process now, and in the process we now have a covalent bond between the two monomers. And so we've synthesized, meaning we put together the two smaller subunits to make a larger molecule. We've dehydrated also because we've removed water. That's what dehydration means. And the whole process takes energy. So you can see the energy is going into the system to make this reaction go forward. So again, macromolecules are synthesized by dehydration synthesis. Dehydration synthesis reactions are important for the formation of polymers from monomers that come from food. So we take in food, we break it down into monomers, and then we build those monomers back up into polymers that actually make up our body. Let's look at the word dehydration synthesis. So the D means reversal. It means reversal or undoing or removing. So in this case, removing something. And hydrate means a solid compound containing or linked to water molecules. So in this case, we're doing dehydration, so we're removing water. So that's where the term dehydration comes from, and synthesis, of course, means you're putting components together, subunits together to make a larger molecule. So we can see a repeat here in this picture of the diagram I showed you earlier. We put two monomers together to make a larger molecule with two subunits. Now we bring in another monomer. We do dehydration synthesis yet again, and again there's the addition of energy into the system. And now we have three subunits in a chain, and we could continue this. So there's yet another monomer here. We could do dehydration synthesis again, and now it would be a chain of four subunits and so forth. So you can see through this process of dehydration synthesis, we can go from small subunits and putting them together and make a very large molecule, a macromolecule. Now, of course, we have to sometimes go in the other direction. We need to break down macromolecules. And the process by which our bodies do this is called hydrolysis. Hydro and lysis. So hydro means water or hydrogen. Lysis means to break down. So we're going to use water to help us break down a polymer into monomers. Okay, so during a hydrolysis reaction, a polymer is broken down into smaller pieces, and the equivalent of one water molecule is added to the products of the reaction. So let's take a look at how this works. So we have here a chain of four subunits, four monomers. We add in water, and actually you see the energy arrows are now going the opposite direction. This is actually a reaction that will yield some energy, so we'll get some energy out of it. But you can see what happens to the water. So a hydroxyl group, OH, will now be attached to one of the subunits, and a hydrogen ion will be attached to another subunit. And so this helps in the breaking down of this chain of four subunits into now a chain of three subunits and a single monomer. So basically this is important reaction, this hydrolysis, and it requires water, and it yields some energy, and it's breaking a complex molecule down into simpler molecules. So hydrolysis breaks down macromolecules into simpler molecules. Hydrolysis reactions are used to break down macromolecules in food during digestion. So every time you eat a meal, you're doing hydrolysis. Hydrolysis reactions are also used by the body to break down complex molecules that are no longer needed into simpler molecules that may be used for new macromolecules. So your body is actually very good at recycling. So if there's something that's worn out within a cell, your cell will actually break those molecules down through hydrolysis into the component parts, the component subunits. And then those subunits are essentially raw fuel or either raw materials to be used to build up a new macromolecule, or they can actually be used as fuels. You can actually derive energy out of those molecules. Okay, so that's all I really wanted to say about this. So we basically covered dehydration synthesis and hydrolysis, which are two very important reactions that occur in biological systems.